right, so today we are learning how to write and solve a proportion. So we should be on page 387. Page 387 in our books. The first thing you need to know is the actual definition of a proportion. It is an equation, so that's a key word. It's an equation that shows that two what? Two ratios are equivalent. All right, so a couple key words in there that you need to remember. It's an equation that shows that two ratios are equivalent. And then you have the proportion example below. 3/5 equals 6/10. Well, as it is right now, it is a little difficult to see if they're equivalent. Does anybody see a connection between 3/5 and 6/10? Justin?
If you reduce if you divide 6/10 by 2, then
Mm-hmm. Okay, so if you reduce them both, they're both 3/5. Could I make 3/5 bigger and make it equal to 6/10? Could I do that? Could I multiply, say, by 2? Would that be true? 3 times 2 is 6, 5 times 2 is 10. So they are equivalent, and I can show that they're equivalent, but even though they're different sizes. Okay, so proportions are going to be ratios that maybe are different sizes, but they still equal each other in their simplest form. Does that make sense? Okay. So I'll give you a minute to finish copying that down. All right, so there are 3 ways that I can solve a proportion. So the next couple sections, now if it says solve a proportion using, and it gives you a specific method, you have to use that method. When it comes to your test next Wednesday, you'll have some options. You can choose whichever method you prefer. So there is a little bit of room in here for you just to use your preferences. So there's 3 ways that you can solve a proportion. The first way, we're going to learn 2 of the 3 today, okay? So we'll learn 2 of them today. The first way is using equivalent ratios, And this is a good method to use when the sides of the ratios that you know have a clear connection, okay? There's a clear missing link, what I like to call it, between the 2 numbers. So in this case, on letter A, how would I get from 30 to 60? What's my missing link? Justin? Multiply by 2. So this is how I want you to show it in your homework tonight. I want you to put 2 in parentheses. Okay? Now, if it's the missing link on the bottom part of the ratio, it's also going to be the missing link on the top part of the ratio. All right? So if 30 times 2 is 60, what's 150 times 2? 300. So my answer is C equals 300. And I box it in. Okay? So finding the missing link and then multiplying or dividing, depending on which way you're going, top and bottom by that number. All right, so I want you to try to do B on your own. So what's my missing link?
3.
Okay, my missing link, very good, is 3. So I put 3 in parentheses, and 7 times 3 is 21, so what's 8 times 3? 24. X equals 24, very good. Now the third one is a little different, okay? Now, again, 2 to 8, okay? So what's my missing link? How do I get from 2 to 8? I can multiply by 4, but I want you to see how this goes both ways. 2 times 4 is 8, right? But 8 divided by 4 is 2. So if I'm going, and in this case, X is what I don't know, and it's in the smaller of the ratios, I can just divide by the missing link to figure out what X is. So 16 divided by 4 is what? Is 4. X equals 4. And I had a few people first hour ask me, well, can I just know that 8 over 16 is 1/2, so 2 over 4 is 1/2 too? You can, okay, that's not a problem. It's just another way to check. But if it says to use equivalent ratios, you need to show the missing link and then box your answer that way. Okay? Yes.
How come you couldn't just multiply 16 by 4?
If you multiply 16 by 4, you're making it bigger, and you're trying to find the unknown for the smaller ratio. So you've got to divide. If you did 16 times 4 is 64, it would not be a proportion because the ratios would not be equivalent. Okay? So X equals 4 would be the answer. Any other questions? Good question. Anything? Okay, moving on now to example 2. So now this is another way, it's just another way that you can solve a proportion. You can solve a proportion using equivalent ratios, or you can solve a proportion using algebra. Now with algebra, you need to remember your keyword starts with an R. How do you solve for the variable? Use the reciprocal, okay? So that's going to be the key word that you're going to remember here. Multiply by the reciprocal. So on letter A, I have 6/10 equals x over 25. 6/10 equals x over 25. Well, I need to solve for x. So how can I get x by itself on one side of this equation? I need to multiply by what? Very good. I need to multiply by 25. That cancels that, and now I just have x on one side, but whatever I do to one side, what's the next step? Have to do to the other. So I need to multiply the other side by 25 as well. Now, should I just do 25 times 6 now? Or is there something I can do to make it a little easier to solve?
Put over 1.
No. What can I do? I can cross reduce, right? Okay. What can I cross reduce by? 25 and 10. I can cross reduce by 5. And now I'm left with 30 over 2 equals x. Well, can I simplify that even more? Can I simplify 30 divided by 2? What's 30 divided by 2?
15.
15 equals x, or x equals 15, either one. Okay? And that's my answer. All right, now on B, I want to show you something. Now, technically, you can use equivalent ratios or algebra if the directions don't say which one to do. But let me ask you this. Is there a clear connection between 14 and 49?
Yes.
Can you multiply? No. I didn't say common factor.
Oh.
I said, is there a clear connection? Can you multiply 14 by something to get to 49? No. So equivalent ratios here is not the practical method to choose because they're 14 times what? Some crazy decimal would give me 49. That would be a lot harder than using algebra to solve. Okay, so sometimes equivalent ratios is the practical, easy way to solve, and sometimes using algebra is the practical, easy way to solve. All right, so on B, what would I need to multiply both sides by to solve for M?
49.
I need to multiply both sides by 49, okay, to get M by itself. Now, McKee, is there anything I can do to cross-reduce? 49 over 1 times 4 over 14? I can reduce by what?
7.
I can reduce by 7. So that becomes 7, that becomes 2. And now I have 28 over 2 equals M. So what's 28 divided by 2?
14.
14 equals M. All right, I want you to do C on your own. All right, so Chris, what do you need to multiply both sides by to solve?
27.
Very good. You need to multiply both sides by 27 because you're solving for C. Whatever side that variable's on, that's the reciprocal you multiply. Raise your hand if you did that. Did you multiply by 27? Good. Okay. Now we multiply the other side by 27. Can we cross-reduce?
Yes.
By what?
3.
We can cross-reduce by 3. So that makes this a 4 and this a 9. So now I have C equals 81 over 4. So it's not going to be an even answer, but what's my answer? C equals
20.25.
20.25, or if you said 20 and 1/4, that's okay too.
Well, can you put a fraction, this number over a fraction?
I would rather it be a decimal because to put a fraction on top of a fraction, like if you were to plug it back into the original proportion, is just kind of goofy. So I'd rather it be a decimal. Okay? All right, any questions on example 2? All right, now before we move to example 3, let's talk for a minute about setting up a proportion. Okay? It gives us this example. It says, yesterday you bought 8 bagels for $4. Today you want only 5 bagels. How much will 5 bagels cost? All right, now, what is important here and what you need to get, there's actually 3 ways that you could set up this proportion and still get the right answer. So what you need to make sure that you do is you compare the same unit on both sides of the proportion, meaning bagels to bagels, dollars to dollars, whatever it is that you're comparing the same thing on both sides of the proportion. All right, so let's say our first ratio is going to be 8 bagels that cost $4 yesterday. Can anybody think of what the other ratio would be? How would I write the ratio for today's bagels? Chris?
5
Very good.
over X.
5 over X, because on the top part of the ratio, do you see that? I'm comparing bagels to bagels. On the bottom part, I'm comparing dollars to dollars. Can anybody think of another way that I could set this up and I'm still comparing the same unit on both sides? Just flip it, maybe? Could I do dollars to dollars over bagels to bagels? Yeah, I could, as long as I'm comparing the same unit. So I could do just the opposite. $4 over 8 bagels equals, I'm not sure how much, over 5 bagels. Again, I'm comparing dollars to dollars on top, bagels to bagels on the bottom. And then there's another way I could set this up. Anybody think they know? It's not going to be bagels to bagels, but
Bagels to
what, Mickey?
bagels to dollars.
Not bagels to dollars. We already did that one. Could I do bagels from yesterday over bagels from today?
Yeah.
What would be the other side?
$4.
Cost, very good. Cost from yesterday over cost from today. And get this. Any one of these 3 ways that you solve will get you the exact same answer. Okay? As long as you're comparing the same units on both sides of the ratio, you will still get the same answer. Now, on the first one, I could use equivalent ratios. Now, 8 to 5 is not necessarily an even number, but if I do 8 divided by 5, I get 1.6. 1.6 would be my missing link. So what's 4 divided by 1.6? Somebody punch it into your calculator real quick. What's 4 divided by 1.6? 2.5. And in dollar form, that would be $2.50. Okay, so that's what I found on that one. Okay, so on the second one, let's just do a little bit of algebra. Multiply both sides by 5. And I get 20 over 8 equals X. Well, what's 20 divided by 8? What's 20 divided by 8? Anybody know?
2.5.
$2.50. Very good. Okay, now on the third one, we could do equivalent ratios again. How do you get from 8 to 4 on the side you know? What's your missing link? How do you get from 8 to 4? That one's easy. How do you get from 8 to 4? Divided by 2. Very good. Okay, so what's 5 divided by 2? I'll give you one guess. 2.5. $2.50. So it doesn't matter, okay, it doesn't matter which way you do it. X is still going to be $2.50. So the most important thing you need to remember is make sure you're comparing the same units on both sides of the proportion and you'll get the same answer. X equals $2.50. Okay, that was way more work than you would need to do on your homework. Okay, you don't have to show all 3 ways. What I'm showing you is no matter which way you choose, as long as you set it up right, you're going to get the right answer. Okay, so out of 17 people in here, you could, one person could set it up one way, another person could set it up a different way, and you could still get the right answer. Okay, so this test is going to be a little bit different for me to grade because there's different ways that you can solve a proportion. Okay, so moving on to the last example, and you need to be looking on with me on page 389. All right, so it says, at maximum speed, the elevators in the Empire State Building can pass 80 floors in 45 seconds. Looks like a ratio to me, okay? Follow the steps below to find the number of floors, so maybe that's what we're looking for, that elevators can pass in 90 seconds. So raise your hand and tell me, what is one of the ratios that I can take from that problem? Justin?
80 over 45.
Very good, 80 over 45. So he did floors over seconds. Would it be wrong if you did seconds over floors? No, as long as the other side was the same thing, seconds over floors. So we have 80 over 45 equals, do we know how many floors?
No.
Over how many seconds?
9.
9. All right, now, based on what we've learned about our two methods of solving, algebra and equivalent ratios, which one do you think will be easier to use in this problem? Which one do you think will be easier? There's only two choices.
Portions using algebra.
Okay, algebra. Now, if you wanted to use algebra, you can multiply both sides by 9. That would be fine. But do you see a clear connection between the sides of the ratios that you know? Yeah, there's a clear connection, and what is that? Multiply by 5. So if there's a clear connection between the sides of the ratios that you know, equivalent ratios is easier than algebra because you can avoid the cross-reducing and all of that. So if you know that the missing link is 5, what's 80 divided by 5?
14.
Not 14, not 15, 16. X equals 16, and what would be my label? What would be my label? Floors. Okay. Now, again, is this the only way we could have set that up? No. Okay. I could have done the opposite, seconds over floors, and I still could have got to the same answer. Okay. So on your homework tonight, there's not just one way to do it, but just make sure that you're comparing the same units on both sides of the ratio. And if you understand that, it's everything you need to know for 8.4.